Hi, my name is Ryan McGuire. I work on test engineering for Cassandra at DataStax. My team and I are always thinking of innovative ways we can test Cassandra to produce high-quality releases. Testing Cassandra performance is not a trivial task. You have several distributed nodes with many different configuration settings. Cassandra is a system that has a lot of parallel processes, and it's all running on operating systems that can get into some pretty weird states sometimes. The list of things that can go wrong is extensive, and when you're attempting to run a scientific analysis of performance where you're only allowed to change one variable at a time, you really need a platform that controls for all those variables in a consistent and trustable way. I've certainly learned it the hard way. If you try to do benchmarks by hand, more often than not, you'll mess it up. Today, I'm super excited to show you one of the things that we've been working on for testing the performance characteristics of Cassandra. This is something that we've been developing over the last year at DataStax called CStartPerf. It's designed to provide 100% automation of performance tests on real clusters. Here, let me show you. CStartPerf presents a web-based front end that gives control over one or more attached clusters. Before you're logged in, this is the screen you'll see, and you can only view tests others have created. You can sign in with any Google account, but the administrator will need to authorize your account for the purposes of creating tests. Here's the main screen for creating the job to compare the difference between one or more test configurations. You start by giving the test a name. You choose the cluster. On this test installation, I only have one cluster, but if you have more, they'll show up here. Revisions represent the individual configurations you want to test. For this example, let's compare three scenarios. The first one, we'll choose to use Cassandra 2.0.10, which is the latest version of 2.0. The second scenario, let's choose Cassandra 2.1. And for the third one, let's choose the same version of Cassandra 2.1, but with a modified configuration to use off-heap mem tables. So let's insert the first revision, Cassandra-2.0.10. If you're familiar with Git, you specify the revision the same way you specify a Git branch or tag. You can also put a specific commit SHA ID here. So in this example, Cassandra-2.0.10 is a tagged release in Git version control. If you leave the rest of the fields blank, you get the default settings. Click the button here to add another revision for our second scenario. For this one, we want to get the latest build for the development release of Cassandra 2.1.0. So we enter the Git remote name followed by the branch name, Apache/Cassandra-2.1.0. Again, we leave the rest blank to use the defaults. For the final revision, we enter the same version as above, Apache/Cassandra-2.1.0, as well as a config option in the box labeled Cassandra.yaml, memtable allocation type, off-heap objects. Now that we have our revision specified, we can move on to the test configurations. This is a list of operations to perform on each revision we specified on the left. So if we leave these two stress commands here, we'll actually be running 6 total operations, 2 for each revision. This tool supports many different kinds of operations. Stress operations, which test loading and reading data. Node tool operations for testing things like compactions or repair. CQLSH operations for your freeform CQL scripts, as well as bash scripts for doing your own thing. For this example, we'll just be doing a simple stress operation. Load, then read. Clicking the green button schedules the job and brings you to a page describing the test you just created. There weren't any other tests queued at this moment, so you'll see that this test is already marked as in progress. We can click here to view the console of the cluster where it's currently running. This is the real-time output of the attached cluster. You can use this screen to see the operations as they're performed, as well as to help debug any problems as they arise. But you don't have to sit here and watch it. You'll get an email when the job is complete. This particular test takes about 15 minutes, but let's speed it up for this video. Okay, the test is completed and I got this email. It includes the link to go directly to the test results page. The test field here shows that the test has been marked as completed. The first thing you'll want to look at on this test is the chart here that's been generated. There's 3 lines on this chart representing the 3 test revisions we specified in the test. The first view is showing us the total operations per second over the duration of the test. In the drop-down here, you can select other metrics to look at, like request latencies. The second drop-down here shows the operations that were defined. The first one shows the loading of the data, while the second one shows reading it back. Overall, we can clearly see Cassandra 2.1 has outperformed 2.0, but less of a difference between the 2.1 revisions. This is a single node running on Amazon EC2, so it's definitely not tuned for performance. This run was just made as an example. Thank you for watching this quick introduction to C#Perf. If you'd like to check out the code or read how to set up your own performance testing cluster, check out the project at github.com/datastax/C#Perf. Have a great rest of your day.